Today we are going to build a simple Android app to kickstart our development journey, and by the end you will be able to create your very own Android apps. To build Android apps, you will need to open Android Studio. If you are not sure how to install it, check out the video linked in the description. Once you have opened Android Studio, you will need to choose between the New Project and Open buttons. Clicking on Open allows you to access your previous projects. Since we don't have any projects yet, we will click on New Project. By default, you will see empty activity selected, but you don't have to choose it. It's based on Jetpack Compose, where both designing and programming are done entirely in Kotlin. However, we will not be using it because some components aren't available there. Instead, select Empty Views activity. Now let's fill in the details. Name refers to the full name of your app, and the package name is a unique identifier that Android uses to recognize your app. It's typically written in the x.y.z pattern, but you can customize it as you like. I'm using com.inventcode.sampleapp. Next, save location is where your project files will be stored, so you can easily edit the app later. After that, we need to choose the programming language. We will select Kotlin because it's the official language for Android development, as declared by Google, the owner of Android. Another advantage of Kotlin is that you can build apps with less code compared to Java. In fact, Kotlin can be seen as a refined version of Java, with additional features that help developers build apps faster and with fewer lines of code. For example, in Java, creating a data class requires more code, whereas in Kotlin, you can achieve the same result with much less. So, go ahead and select Kotlin. Now let's select the minimum SDK required for the app. I'm choosing Android 8, also known as Oreo. This means the app will not work on devices running below Android 8. I selected this because the latest Android version is 15, and I don't think many people nowadays are using below Android 8. Google releases new Android versions with some new features. For example, from Android 6 to 10, we could access all files with a single permission. But starting with Android 11, the method for accessing files has changed. So if you select an older SDK version, it will be difficult to manage your app for all devices starting from that version. Now set the language for build.gradle to Kotlin. Gradle is the build automation tool that manages the entire development process. It handles tasks such as compiling the code, generating the APK file, and managing IDE errors. In simple terms, it's the engine behind Android Studio. By the way, don't forget to turn on your internet connection, as Gradle will need to download the necessary files for the project. Finally, click the Finish button. Now, Gradle will download the necessary files and set up the environment for development. We have to wait until it is complete. First, let's talk about the Android manifest file. The manifest is the root configuration file of your app, where you can declare permissions, set your app's name and icons, add or remove activities, and more. In the application tag, you'll see the name of your app. You can change this directly. But it's better practice to use strings.xml for text resources. By placing your text in strings.xml, you can easily manage and reuse them throughout your app. As you can see, there's an activity declared here called main_activity. This is a Kotlin class that extends app_compat_activity. In Android, an activity represents a screen of the app. Since we chose Kotlin as our programming language, the class is written in Kotlin. You can start by removing these lines. Now we can see the setContentView method, which sets the layout for the activity. Activity main.xml is the layout file where we design the screen and add components. Currently, there's a text view component present, which is used to display text on the screen. You can modify the text as needed. Additionally, you can use the strings.xml file to organize your text resources. For example, in the text attribute, you can choose @string/greeting, where greeting is the name of the text resource. You can also adjust text size, color, and style. If you want to display the app's name, you can simply use @string/appname, as it's already defined in the strings.xml file. This way, you avoid writing the text directly in multiple places. Now let's go back to main activity.30. Suppose you want to control the text from here. To do this, you need to assign an ID to the text view. Next, initialize the text view in your code. You can declare it with val, give it a name, and then specify that it's a text view. After that, use the findViewById method to reference the text view from the layout. Once you have the reference, you can set the text, change the colors, and more. Just like strings, we have a colors.xml file where you can define the color and use them throughout your app. To get a color resource, use the getColor method, and to get a string resource, use getString method. In Kotlin, you can use the apply method with any object to simplify your code and avoid repeatedly referencing the object. For instance, you can configure a text view using apply like this. With apply, you don't need to mention the object name multiple times. This makes your code cleaner and easier to read. If you don't need to refer the object again, you can just use apply to set its properties in a more concise way. Changes made in the activity class won't be visible in the preview section. To see them, you need to run the app on a real device. You can use a virtual device or emulator too, but if you have a low-end device like me, the emulator might cause lag or instability. In this case, we will install the app directly on our mobile device. To do this, go to your device setting, then navigate to About Phone or About Device and find the build number. Tap this button 8 times repeatedly to enable developer options on your device. Go to Developer Options and turn on USB debugging. If you want to view your device screen on your PC, you can use Screen Copy. It's a free and open source software. With USB debugging enabled, connect your Android device to your PC. Open Screen Copy and it will display your device screen. In Android Studio, after connecting your phone and enabling USB debugging, you should see your device listed. By clicking the play button, Android Studio will compile the code into an APK file and install it directly on your mobile device. You can see the text and its color have changed. Let's talk about another component, the button. In XML, add the button component. The button will take up only as much space as needed, while match parent means it will expand to fill the entire available space. Next, add text to the button. You will see an error because we are using a constraint layout, but haven't set any constraint yet. Let's fix that. I also want to add more space above the button. So add margin top. In XML, dp is the unit for dimensions, similar to kg or seconds. However, dp is variable and it's automatically adjusted based on the screen size. Lastly, add an ID to the button. What I'm gonna do is set up the button so that when clicked, it will increase the count displayed in the text view. But first, let's disable the dark mode as I prefer not to use it. Now open the main activity class and find the button. We want to increase the count each time the button is clicked, so set an on-click listener for the button. Inside this on-click listener, the code you write will be executed every time the button you click. For example, you can use an integer variable initialized to 0. We use var because var can be changed easily, but val is immutable and cannot be changed. Inside the on-click listener, increase the count. To display the updated count, set the value to the text view. Let's test it out. You might wonder why we are using a variable. Well, we could manage without a variable, but using a variable helps us handle the count more efficiently. If we didn't use a variable, we would need to extract the count from the text view, convert it to an integer, and then increase it. Here's how we can do it. First, get the text from the text view. Since the text view includes both the number and the count word, you need to remove the word and extract the number. Use the replace function to remove the unwanted text. The first parameter of the replace is the text you want to remove, and the second is what you want to replace it with. In this case, an empty string. Then convert the result into an integer. Increase the value and set it back to the text view. Since text view only accepts strings, you need to convert the integer back to a string. However, this approach is not the most efficient or recommended. It's better to use a dedicated variable for counting. If you want to write clean code, you can create a method to handle the count updates. First, add a global variable to keep track of the count. By defining this variable globally, it will be accessible from both onCreate method and the new method you create. In this new method, increase the count and update the text view. Similarly, declare the text view as a global variable. In Kotlin, you don't need to use findViewById in the onCreate method for this. Instead, you can use the lazy extension for efficient initialization. The first method is onCreate. This method is triggered when the app is launched, meaning the activity is created and ready to work with. That's why we initialize and manage components inside the onCreate method. Another method is onPause. This is called when the app is minimized. It allows you to take some actions before the app is fully minimized. Then there's onStart, which is triggered when the app becomes visible, such as when it's opened from a minimized or invisible state. Next, we have onDestroy. This method is fired when the app is killed or the activity is about to be destroyed. However, this isn't the last method. There are more lifecycle methods available. Using these methods, we can do whatever we want according to the state of the lifecycle. Suppose I want to show a toast message based on the lifecycle callbacks. Let's start with the onCreate method. To show a toast, we use the toast class with the static field makeText, where the first parameter is the context, the second one is message, and the last one is the duration. Now I'll copy and paste this code for all the lifecycle methods. Let's test the application. As you can see, when the app is launched, it shows the toast for onCreate and onStart method. Because after the activity is created, it becomes visible to us. That's why onStart is also fired. Now if I minimize the app, it will show the onPause toast. Then if I open it again, the onStart toast will show up. I hope you now have a basic understanding of building Android apps. In the next video, we will be creating a browser-like application, so stay tuned.